discuss about a continuous probability distribution, continuous distribution function and continuous. Obviously this one is with respect to continuous random variables. So continuous random variables here, first we define the continuous random variable. Continuous random variable. Random variable. Continuous random variable. Continuous random variable. So if random variable is defined for all values for a class interval, then that random variable is called what? That random variable is called continuous random variables. For example, as earlier we say that height of any person, height of a student, or means age of any student is what? Continuous variables. So if a random variable, RV is defined for each value for a class interval, then that random variable is called what? Class interval. Then random variable is called continuous random variable. Continuous random variable. Continuous random variables. Now, if we try to associate the continuous random variable with what? With the probability distribution. Means if we define the associate probability with the random variable for a class interval, means what is the probability for a certain class interval? We cannot define the probability at a certain point in case of a continuous random variable. So first we define the what? Probability density function. Probability density function. Probability density function. Like in case of a discrete probability distribution, there is a probability mass function, but in case of a continuous, there is a probability density function. A function fx is said to be probability density function PDF, probability density function if a function fx is said to be a probability density function if fx is continuous and fx dx represent the probability represent the probability in a small interval, in a small class interval of x. Means x, small class interval of x and x plus d. It's like this one. In a small class interval. In a small class interval, if we write a small class interval. If we try to define like this one, fxx equal what? This one is a limit delta x tends to 0, probability of x greater or equal to what? Less or equal to x plus delta x, and greater or equal to what? X minus delta x. X minus delta x, not x minus delta x. Probability of what? Probability of x, capital X. Sorry, this one is capital X, small x, divided by what? Divided by delta x. Delta x. So, for sake of simplicity, we try to elaborate this one graphically, means geometrically. This one is a what? This one is a suppose fx. This one is a what? This one is a fx. This one is a fx. And this one is a what? This one is x. And this one is a very small. This one is a dx. And this one is a x minus dx by 2. And this one is a x plus dx by 2. And this one is a what? This one is a dx. This one is a dx. 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 Then, if fx represent what? Fx dx. Fx dx. Fx dx represent the probability for this small class interval. For this small class interval, if this one represent the what? This one represent the probability. Probability in this small class interval. Probability in small class interval. In small class interval. Interval x minus dx by 2 and x plus dx by 2. Then this one is called, then fx is called what? Fx is called probability density function. So, if we try to clear this one more, if we try to write this one in terms of probability, means the probability of x is greater or equal to alpha, less or equal to beta, then this one equal to what? This one equal integrate alpha to beta fx dx. Fx dx means this one is a what? This one is the area between this one. We try to elaborate this one graphically. This one is a what? This one is fx. Fx. This one is alpha, and this one is what? Beta. Then this area represent what? Represent the probability between x is a greater or equal to alpha, less or equal to beta. Then this fx. Then this fx is called what? This fx is called probability density function. Probability density function. Now, what is the property of a probability density function? If we try to discuss about the property of a probability density function, obviously, like discrete probability distribution, probability mass function, sum of a probability equal 1. But in this case, what will happen? Area from minus infinite to infinite. Fx dx equal to what? 1. Sorry, not to 0. Fx dx equal what? Fx dx equal 1. Area from minus infinite to infinite, fx dx equal to what? 1. Means, for example, suppose this one is a curve, this one is a curve. This one is defined from minus infinite to infinite. Infinite to infinite. This one is a what? This one is a fx. This one is a fx. Then total area, this total area means integration of a minus infinite to infinite fx dx equal 1. Then this one is called what? This one is called probability density function. Otherwise, this one is not a probability density function. So, this one is a probability density function. Like discrete distribution function, there is a continuous distribution function. So, how we define the continuous distribution function? So, here if we try to define here continuous distribution function, how we define the continuous distribution function? So, if we try to define continuous distribution function here, continuous distribution function. continuous distribution function. Continuous distribution function. So again, this one is a what? This one is a cumulative distribution function for the continuous random variables. So this one is also defined as what? Fx equal what? Fx equal probability of x is less or equal to x, and this one equal what? X is less or equal to x. Means this one in the left hand side, this one tends to what? Minus infinite. So this one is the area from minus infinite to x. Fx dx. Fx dx. And here x ranges from what? X ranges from whatever the value. X ranges from again greater than if we write here greater than x is a what? The value of x is a greater than minus infinite less or equal to infinite. So this one is a what? This one is a continuous distribution function. As we know that in a case of a continuous distribution function, again here we say that what is the value of probability of x is a greater than a less or equal to b equal to what? F of b minus f of a. So what is the probability? A less or equal to x less or equal to b. So this one equal to f of b minus f of a. You may also write this one is equal. So because at x equal a, what is the probability? At any point, at any particular point, what is the probability? In case of a continuous probability distribution, probability is the same. So in this case, how we prove this one? Probability of this one, not a here, whatever you write, either less or equal or greater or equal, but if we write a greater or equal, then it's become easier to prove this one. Probability of a, x is a greater than a less or equal to b, plus probability of x less or equal to a equal to what? Probability of x less or equal to b. And then this one equal what? Probability of x is a greater than a less or equal to b equal what? Probability of x less or equal to b minus probability of x less or equal to a. Less or equal to a. Now what is the probability of this one? This one is a minus infinite to b. Minus infinite to b fx dx. Fx dx. And this one is a minus of a minus infinite to a fx dx. Now using the property of a definite integral, if this become plus, then minus or we write this one in this way, if what? Here x is a greater or equal to a, if a is a here like this one, a is a less than b like this one. So if a is a less than b, so here if we use the property of a what? Minus infinite to b, and here we use the plus, then this become what? Here a to infinite, a to minus infinite. So here if we use the property of a definite integral, then where we write? We write here. We write here. We write here. Then what will happen? Then probability x is a greater than a less or equal to b equal what? If we write this one first, or we write this one minus infinite b fx dx plus, if we write this one using the property of a definite integral, if we change the limit, then this become plus. Plus, what will happen? A to minus infinite fx dx. So again using the property of a definite integral, a to minus infinite, then minus infinite to b. then this become what? This become A to B fx dx. This one is nothing else probability of x greater than A less or equal to B. And in case of a continuous probability distribution, again I emphasize this one, particular at any point what is the probability? Probability equal 0. So here, what is the value of this one? The value of this one become probability of x greater or equal to A less or equal to B, and this one equal again probability of x greater than A less than B, and this one again probability of x is greater or equal to A less or equal to B. Means all the cases, what is the probability? Probability is A to B fx dx. So this one is a one property. Similarly, you may write this one f of b minus f of a. This one is your f of b minus f of a. This one become what? F of b is simply this one is the probability of x is less or equal to b minus probability of x is less or equal to b. This one is f b minus f a. This one is equal to probability of a x is a greater than a less or equal to b. So this one is a what? This one is a continuous distribution function. Now next two topic is a what? Next topic is a expectation.